Hello students, welcome back. So now we are going to talk about the types of digital systems that we have and that we are going to implement in this training program. So in this video, we are going to talk about the types of digital systems. There are two main categories. The first one is combinational systems and the second one is sequential systems. So let us get started. So in digital world, we have circuits and systems. The smaller assemblies are called circuits, and when we join multiple circuits for a larger purpose, we can call that as a system. There are two major categories for digital systems. The first one is called combinational circuits and the second one is sequential circuits. Both of them, when put together in larger sizes, can make combinational systems and sequential systems. So let us talk about the combinational circuits. These are the circuits which do not have any memory. That means they do not depend on the past values of outputs. In these circuits, the outputs will always depend on the current value of inputs. Here we need logic gates to implement. We don't need more elements, we just need logic gates. And you know logic gates are AND gates, OR gates, NAND, NOT, NOR, exclusive OR, exclusive NOR, and there are many more. All of them we will be studying in this training program. These circuits and systems are mostly used to implement arithmetic operations. Let us have a look at the block diagram. I can have n number of inputs. Then I am going to connect them logically using these logic gates, and that is going to make my combinational circuit, and I am going to generate one or multiple outputs. Now you can see that the output value is dependent only on the current inputs. Some of the example of combinational circuits are, or combinational operations are, adding two numbers, multiplying two numbers, getting the square root of a number. So these are the operations where I don't need any other information. I just need the input and I will calculate the output. So let us talk about some standard combinational blocks and modules. What are blocks and modules? So what we do when we program, we do not keep on writing the code for a particular circuit again and again. We will make the code once, and then whenever we use it, we will just call it. So these are called blocks, and the larger blocks or the main one is called module. So we are going to make arithmetic operations such as adders, subtractors, multipliers. We are going to implement shift logic circuits, multiplexers, demultiplexers, encoders and decoders, comparators. So students, we are going to discuss them in detail in our incoming modules. So these will be implemented once and they will be used in the larger system implementations. Coming to the sequential circuits, these are the ones which have memory element. They will have a track of previous output values. They are the building blocks for memory elements like random access memory, RAM, read-only memory, ROM, and any other memory that we have. So let us have a look at the block diagram. I have inputs, I have sequential circuit, and I generate the output. But a part of the output is taken back to the input. Now what is the purpose of it? Let us understand with one example. If I ask you that you have to count from 1 to 5. So your first output is 1, and then you are going to generate the next output. To generate that, you need to know that what was my previous output. My previous output was 1. I will add 1 to that and generate 2. Now my current output is 2. For the next output generation, I need that value. I need to store that. And that is why we call that these are the circuits with memory elements. Some of the standard sequential blocks and modules that we are going to implement and study in detail are latches. These are the basic elements which can hold 1 bit of data. Then we have flip-flops, which are very similar to latches with some slight differences that we will discuss. Registers are the combinations of multiple flip-flops, and registers can also shift the data and then they become shift registers. We are also going to discuss counters, RAM, dynamic as well as static, and finite state machines. So these are the things that we will do with sequential modules. So if we compare these two types of circuits, then we can see that combinational circuits, the output depends only on the current values of inputs, whereas in sequential, the output depends on the current as well as the past values. Combinational circuits are faster in operation. Sequential circuits obviously are little slower because they need to have the memory elements also. In combinational circuits, we don't need any triggering circuit or triggering signal, whereas we need the edge or level triggered signal in terms of a clock for sequential circuits. Combinational circuits are purely made of logic gates, whereas in sequential circuit we need flip-flops. Combinational circuits are mainly used for arithmetic operation and logical operation. Sequential circuits are mainly used for storing the data and other memory related applications. So students, I am sure that now you know that there are two types of digital systems and what are the main circuits or system under those two categories. Next, we are going to talk about the digital system design flow, that how do we design any digital system. Keep learning. Thank you.